I think it's just the breadth of topics that they have here. It's like the smallest things that C++ offers us to like the broad eagle eye view on like architecture, software architecture, and other topics as well. So it makes it unique in that sense.
Hi, I'm Thomas Lane Cassell, and today I'm going to talk about why concurrency works in C++. So how do we get concurrency in the first place? In a nutshell, we create threads. These threads run on a scheduler, and then the scheduler makes guarantees to these threads. But what are these guarantees? So the first guarantee that exists in C++ is concurrent forward progress. So this means a thread will always make progress. Seems simple enough. What other possibilities could there be? The next one is parallel forward progress. This means a started thread will make progress. So once that thread has started, it now has concurrent forward progress. So in concurrent forward progress, we can guarantee our thread will always run. But in parallel forward progress, we can't rely on any threads that haven't started running yet. Any more? The final one is weakly parallel forward progress. And this states there is no guarantee that a thread will make progress. And this sort of forms a hierarchy. So weakly parallel forward progress is a subset of parallel forward progress, which is a subset of concurrent forward progress. But what actually is progress? So the standard defines an execution step. You can read it there if you like, but basically, a thread makes progress when the execution step occurs. Or, in simpler words, whenever the thread interacts with the outside world. So this relates to execution policies. So we have the most basic execution policy here. Std execution sec just means sequential execution, nothing fancy. We also have std execution unsec, which means single-threaded vectorization. So our code will be vectorized, but will still only run on a single thread. The next policy we have is std execution par, and this actually provides the parallel forward progress guarantee I was talking about earlier. And finally, we have std execution par unsec, which does weakly parallel forward progress and vectorization. But if you notice, there's a small gap here. Some algorithms may run under weakly parallel forward progress, but are unable to be vectorized. And so you have to use parallel forward progress instead of execution par in that case. But wait, earlier I said weakly parallel forward progress means there's no guarantee a thread will make progress. So how do we know our thread will run in the first place? Luckily, the standard has this nice corner case covered, and it has this thing called blocking with forward progress guarantee delegation, which means any blocked or finished thread may delegate its forward progress. So as long as the main thread has good forward progress, that means it will delegate its forward progress down to the threads that it's running to ensure that they're all complete. Thank you for my talk. Here are the references. I really recommend this forward progress guarantees talk by Oliver Giraud from CppNow 23. It is really fascinating and covers lots of depth. Thank you for listening.